Hello, my friends, and welcome back. And today I'm going to be showing you a project that I'm currently working on, and it's pretty much a chatbot called Aesthetic IQ Assistant. And what I'm building is an ingestion pipeline in Databricks. And today we're focusing on the most underrated part of it which is configuration. This configuration cell that you guys are going to see lower down is a settings page for the project. So it talks about the table's names, file location, chunking rules, and run controls. And once you set this up, the rest of your notebook becomes clearer, safer, and easier to explain. Now, if you've ever built a notebook and then later changed one path and suddenly 12 cells broke, this is the fix. Well, this has been my fix in this video. So I'll show you how to create a single source of truth configuration. So change settings is all in one place. Now what you'll see starts actually in cell 5. And so your change settings in the whole pipeline stays stable. And so what we're going to be looking at is here we have at data class frozen equals true. Now, this line is actually doing a lot. A data class automatically creates the boring parts of a class for you, like initialization, so your config stays clean and readable. And frozen equals true makes the configuration immutable after it's created. That matters because configuration should not randomly change mid-run. Freezing pretty much helps prevent accidental edits like overwriting a path and writing outputs to the wrong place. So think of it like your settings are locked after you press save. So next, what we have are the Unity catalog table names. In Databricks, I like three-part naming. So catalog.schema.table. And this keeps my data organized and avoids the where did the table go? Um, Now, chunks table is where we store the chunk text in bite-sized pieces of document content. And you'll see that as I go. Now, the other table that you're going to see me have is the documents table, and that stores document level data. So, for example, file name, hash, source path, and ingestion date. And the failures or ingestion log name table is the safety net. It's something, if something breaks down during ingestion, we log it. So debugging is fast and repeatable. The next area that I'm going to talk about is the input location. So this is the location where my PDFs live. I'm using a volumes path so the notebook can reliably access the same directory. So if I ever move folders later, I can update this one line, not 10 cells that reference a node path. And so one of the biggest mistakes that I made when I was learning to code or at my previous positions of employment is hardcore coding the paths where my projects or my data or where my PDFs live. All right, so what we're going to be talking about here is chunking controls and how we split document text into smaller pieces for embeddings and retrieval is all through pretty much chunking. So if the chunks are too big, retrieval gets messy and we can exceed context limits. If chunks get too small, we could lose meaning and some of the answers that we get from it can get worse. So here we have tokenizer ID, and this matters because chunking and tokens maps better to how language models read text than raw characters. And so this is pretty much the tokenizer ID, the meta llama is what we're using for this mapping. Now, max tokens per chunk is our chunk size. So for me, a reasonable starting range is about 400 to 700 tokens, which 500 for me is a balanced default. Next, we have the separator. So the separator is defined by the order of how we're splitting text, from clean splits like paragraph breaks to last resort splits. So we could think about it first paragraph, then lines, then spaces, and then the fallback to character level splitting. We're pretty much just coding how we want this data to be split up. So next we have the safe, what I would call the safe testing controls, where we have the dry run and max files. So these run controls let you test safely. Dry run means that you can validate the pipeline logic without committing full writes, depending on how your notebook is wired. Then I have the max files. Now the max files lets you start with one document, confirm the outputs look correct, then scale up. You can think about this as like my own protection habit. Test on one file, then increase the max files. So now we have this compute content hash flag control, and this is where I generate a deep hash of the document content. So sorry, I can't talk now. If this is set to true, the pipeline does extra work to fingerprint the document. Now you may ask, why do I have this? And this is useful for detecting duplicate content or any document changes, but it does cost more to compute. Right now, let's set it to false because I'm optimizing for speed while developing. Okay, now we have the fail fast behavior. This is something that I am still, well, there's two ways for me. Fail fast is if something isn't working out, go on to the next thing. Now this fail fast flag controls how the pipeline reacts to errors. So if this were set to true, the pipeline would stop immediately when it hits an error. This is great for strict production environments, but during development, I want visibility, not silence. So I keep it false and log failures instead. So that's why I'm like, oh, there's two fail fasts. One for if something isn't working out, fail, move on, and try to figure out the solution. This one is I want to see what's up. And lastly, I have the config. So this is the handoff point. Once the config is initialized, the pipeline behavior is logged in and consistent everywhere. So this line activates the config and applies all those rules across the pipeline. So this is pretty much the end of this video, and if you found anything here helpful, please feel free to like and subscribe to my content. It really helps. And we pretty much just went over table names, file location, chunking rules, and run control. Once this set up, it should make our notebook and project a lot cleaner, safer, and easier. Thank you guys very much for watching, and I will see you in the next chunk of code because there's still more after this. So if you like what you see, like and subscribe, and I'm going to keep posting my content.